In this recording, we're going to learn some key components of quadratic functions. This would be an example of a quadratic function right here, and its corresponding graph looks like this, and we've looked at that. It's called a parabola. And so we're going to get a little vocab. We're going to start to get a little more specific about how some of the points have names, and they tell us particular things about the graph. So, as it says here at the beginning, we have a quadratic function represented three different ways, and that's a big concept in algebra, is different representations and their connections. So we have a quadratic function, which is written as an equation, a table of values, which is right here, which we're about to complete, and then a graph, which you obviously can see there. So the first task we have here is to complete the table. Oftentimes, and we'll do this in the future, you won't have the graph. You will start with the function, come up with the table, and then produce the graph. But we happen to have the graph here, created by a computer, and now we're going to identify points between -3 and 3 in the x, and their corresponding y's. So you'll have something like this. Okay? What I need you to do now is find the corresponding value of m. That's basically saying y, right? The m of x is the y value that goes with that particular x value. So if you were to come over to -3, I want you to see if you can identify the y value that corresponds to -3 on the red graph. So hopefully you went over to -3 up to where the graph is at -3 and you identified that it's +8. It's a little hard to tell what that number is, but you can pretty much figure out from counting. It goes up to 8. So can you complete the rest of these y values, please, and then play the recording when you're ready. Okay, so hopefully you took time to do that. Next question. Where does the function intercept the y-axis? Okay, so right here is where it intercepts the y-axis. It's called the y-intercept, and that's the value 0, -1. We like to write our intercepts as points. They have an x and a y. And any point along the y-axis obviously has that x value of 0. That's an important characteristic. How would you obtain this point from the equation? Well, let you think on that a little bit. We just mentioned what we know about all points along the y-axis. Okay, so hopefully you thought about that for a second and considered that the x would have to be 0, and I could substitute 0 into the equation for x. Okay, like we said here, if you substitute 0 in, we can say this two ways. We can call it m of 0, that's function notation, or we can say y equals. And when we substitute 0 in for x, 0 squared is 0, -1 is -1, so we'll get -1. That has a fancy mathy name. It's called the y-intercept, and you're familiar with that word in other functions that we've looked at. Let's label it right here. Okay. Finally, it asks us, what is the y-coordinate of the lowest point on the graph? Well, put your pinpoint on the lowest point on the graph. Hopefully you're there and you can identify its y value. So that would be -1. So what's the relationship of this value to the vertex? Well, that is the vertex. That lowest point on the graph is the vertex, and this is the y-coordinate of the vertex. And where does this function intercept the x-axis? Well, I'd like you to put your finger on one of the places where it crosses the x-axis. Okay, so you have a couple options here. There's one, and there's another place. Those are called the x-intercepts. Okay, so we see two different points. Okay, so those are the x-intercepts. They both have y values of 0, right? Because it's all across that line on the x-axis where the y is not up or down, it's 0. All right, cool. Next, show an algebraic process to get these x-intercepts. Excuse me. Well, we know that the y is 0. In other words, the m of x is 0. So I can start with that function. And in place of m of x, I can substitute 0 because I know that the y value is going to come out 0. Now I can just do a little math to get x by itself. If this were just x minus 1, you would know what to do to get x by itself. You'd add 1, right? So I'll just try to make a little space over here. So that's going to be 1 equals x squared. Now, we don't have x solved for yet, but we can undo the square with a square root. Okay, square and square root are inverse functions. Now, there's some more sophisticated things we're going to talk about in terms of square rooting squares, but I guess for now, let's just use our mental math. What number or numbers can you think of that when you square them, you get a 1? That's what we're asking. And hopefully you realized 1 squared is 1. Well, there's also another number. It's negative 1, because negative times a negative is a positive, and that is the solution set. So, okay, where are these numbers going? Well, those are the x's that are going to give us y's of 0, right? So we just made a connection between what we saw in the graph and what we can figure out algebraically from the function equation. Finally, let's connect to our other representation, the table. If you were to look up 0 on the table in the y's, would we see our x-intercepts? Yes, we would. Right there and right there. So we're making connections between all of those three representations. And finally, it's asked, look at the table. Is there a point where the where the values for m of x begin to repeat? Well, let's look at the table and see if we see something like that. So the y values 8, 3, 0, negative 1, and then it turns over. So right there, that's where we see repetition. That has a special name. That's called the vertex or turning point. Let's label that down here. That is the point, 0, negative 1, and it's called the vertex or turning point. So now that we've kind of explained a bunch of things here, let's see if you can take this second example and just do it on your own. You've got 3 different representations, table, equation, and graph, all of the same quadratic function. And you might notice this one's in a little different form. I don't see the x squared like I do in the previous one, but I still know it's quadratic because I have x times x. So I know I'm going to end up with a quadratic in there. It's just in factored form. And that form is going to give us some information that the other form did not. So see if you can, for these x values, set up your table, find the y values from the graph, and then let's see if you can answer questions A and B. Okay, so hopefully you took time, you paused, you worked that out on your own. If not, please do that now. Okay, if you're saying, where are you getting these x values? How do you know which ones to use? You could use any x values in theory, but this is saying for x values that are greater than or equal to negative 2 and less than or equal to 4. So it's specifically establishing a domain for my table. I get these values. So for negative 2, I'll just show you where I'm seeing the first one in case it's unclear. Negative 2, I go over. I say, what is the y value on the red graph when x is negative 2? And it's 0. So I know the y value, or f of x, f of negative 2 is 0. Question A. Looking at the table of values, what values is h of x equal to 0? Well, hopefully you identified those points. Just ask me for the x values. And now it says, looking at the equation of h of x, describe a way you would find these x-intercepts. Well, let's see what we know again. For x-intercepts, let's just make a little note here. That's where the what is equal to 0. All right, all along that graph, along the x-axis, y is equal to 0. So when you see x-intercepts, you can immediately know that y is equal to 0. So we can say is these are the values of x that would make each binomial factor equal 0. So in other words, what's going to make this factor right here equal 0? What x value could I substitute in so I'd get something minus 4 equals 0? Well, of course, that's 4, right? So if I substitute in 4, 4 minus 4 is 0. And then 4 plus 2 is 6. But when I multiply those, 0 times 6 is 0. So when I substitute in 4, we get 0. Let's try the same thing with the other number we said, negative 2. So if I were to sub in a negative 2, let's see how that works. Negative 2 minus 4, well, we know that's negative 6. And then negative 2 plus 2, yep, that's a 0. 0 times anything, the whole thing is 0, right? So that's the effect of subbing in a negative 2 or a 4. Finally, the question says, describe the shape of the parabola. Okay, so we just look at this parabola. It's kind of U-shaped, and I would say it continues to spread to the left and right. Why don't you take your pen and add arrowheads to that? Continues in the left and right direction. And we'll get more language later to describe the shape. Thanks for watching.